Today's class is on wave optics and the part is interference, and it is class number 13, continuation of class number 2, and it is specifically on fringe position, fringe width and part difference. And this class is very exciting on the point that I will just solve out 12 solve pattern from the NEET, JEE and IIT. So minutely follow the class with cool mind. You will find each and everything is very easy. So before continuation of this class, let me just explain a short or a little about the young double slit experiment, where this is the source, and from this source we have just chosen two slits S1 and S2. The distance between these two slits is small d. So small d is the distance between the two slits S1 and S2, and here it is a screen, and from slit to screen distance is d, and here from center fringe to a specific point P the distance is x, and the smaller in the formula will come, it is nth fringe, fringe number 1, fringe number 2, fringe number 3, like is small n. And now what is beta? Beta is the fringe width. Say it is white, it is central fringe, it is known to you all. If center is white, so next one is black, again white, black, white. So from the below in the same way, it is black, white alternate in this way. We get this one. So now what is fringe width? How much fringe is? Fringe width is, that is fringe width of white fringe width is between the distance between two black fringe width. This will give you the width of bright fringe, and in between two consecutive white fringe will give you the fringe width of black, dark. So this is beta. So our today's solutions are 12 pattern of NEET, JEE and IIT solutions, and the pattern is chiefly based on this small formula. One is nth BF, bright fringe, is means from the center dark, bright, 1 2 3 4 5 6. This is nth. What is number of n for bright, number of n for dark, number of n for bright? That gives you small n, and the total distance x is equal to n lambda d. So the very important fact is that nth, what is the number of the bright fringe, is equal to n into the distance from the center fringe, x is equal to n into lambda capital D by D, where n is the number of the fringe, 1 2 3 4 5th, like this. So nth of dark fringe is equal to twice n minus 1 into lambda into D. So mind that nth bright fringe is always is equal to, part difference is equal to n into lambda, where n is even number, part difference is n into lambda, and for dark fringe n is equal to twice n minus 1. This is odd multiple. If it is even multiple, this is p is equal to even multiple in lambda, this will give you bright, part difference is equal to odd multiple in lambda, this will give you the dark. So next we know the formula is fringe width is lambda d by d. It is known to you in my earlier class. I have mentioned, I have given you the formula, I have not mentioned. And next one is n1 lambda 1 n2 lambda 2. I will explain in due course of time of the solution of the pattern of the question asked in the entrance or NEET, JEE and IIT. And part difference in lambda is equal to lambda, part difference is equal to lambda by twice pi into 5. So let us start with the first formula. So minutely, just you please go through the questions, and it is very easy. You can solve it very easily. Just strike the point. What is the point you have to understand and you have to catch? The point is young double slit experiment, 10th order of maximum 10th order of maximum is obtained at a point of observation in the interference pattern for lambda is equal to 700,000 Armstrong. When wavelength of source of light of 700,000 Armstrong is used, the maximum is obtained at 10th position, that is small n is equal to n when lambda 1 is equal to this. So you are getting small n is equal to 10 when lambda 1 is equal to 7,000 Armstrong. And it is now told if the source is replaced by another one of wavelength lambda equal to 5,000, just sources other systems all remain same, that is your lambda, your d, your lambda d and distance of skin between the slits of skin and d and small d and x, each everything will remain the same, only the source is changed here. Source is 5,000 source of light, wave is 5,000 Armstrong. Now there will be a maxima will obtain at some position of n, we don't know. You are asked if lambda 2 is equal to 5,000 Armstrong, then what will be the position of that fringe of maxima? Very simple, very simple. I told you n1 lambda 1 is equal to n2 lambda 2. So n1 lambda 1 saman is equal to n2 lambda 2. So what is n1? n1 is equal to 7,000, and you are asked to find out this. So very simple. The question is huge and big. Just to go to the question and find the clues, and you need to know which formula you like to use is n1 lambda 1 is equal to n2 lambda 2, because the source is lambda 1 and lambda 2, with lambda 1 lambda 2 and n1 and n2, n1 is equal to n2 is not given, so n1 lambda 1 is equal to n2 lambda 2 should be used. You just to put the value, will find the result. This is question from AI triple. Again, question is very simple. Just to go through, within a second we will solve this one. In young double slit experiment, so lambda for red light is found to be this one is used, and lambda for blue light is this much, and the value for n, we don't know what is that n, means what is the number of the nth number of the fringe is not known, for which n plus 1, n after n, if it is 5 then 6. If you are asked to find out n for which the next one blue light fringe will coincide with nth red, so blue and red will coincide for what value of the fringe n, that two will coincide. When there is a question of coincides, so you blindly use n1 lambda 1 n2 lambda 2. So what you are given here n1 is say n, and for that your value is 7.5 into 10 to the power 15, and for n2 it is given n1 plus 1, and that too coincides n plus 1, and lambda 2 is here 5 into 10 to the power 5. So on solving, you will find that 7.5 2.55, so 10 5 2, n is equal to 2. So the value again for n is 2, and n plus 1 means third, and 2 and third, 2 is for red and third is for bright. They will coincides when the two wavelengths of red and blue lights are used in the Young's double slit experiment. Pattern from the IIT and JIT. JEE is third one is Young's double slit experiment. Distance between the two slit is made 3 times. Then fringe length, what will be the fringe length? That is, the slit distance is this is the two slit distance, and it is made 3 times of the initial one. Now what will be the fringe? What will be the change in the fringe? Now what is B is equal to lambda d by d. That is beta is inversely proportional to d. If distance is changed 3 times, so beta will be 1 by 3 times. The fringe width will be 1 by 3 times of the initial one, because distance is changed to 3 times. So now again go to the question, and you are asked the two slits S1 and S2 is used in the young double slit experiment, where the phase difference is found to be lambda, phase difference is found to be 0, and slit S1 SL2 and the wavelength lambda is used. Will show destructive, and that experiment will show a destructive interference at point P. At point P, a destructive interference will be shown, that is S1 and this is S2. A destructive interference will shown, and this is the path difference. Am I right? This is D and this is D, and if it is center from this is X, this is center fringe, like this. In short, I have drawn in graph. This is P point, and you are asked that if phase difference is 0 and S1 S2 are two slits as a common wavelength, lambda is used in the experiment, and you are asked that arrangement of the experiment will show destructive interference at point P, not constructive. It will show you destructive interference. Then the path difference will be, for destructive interference, S2P minus S1P is equal to twice n minus 1 into lambda by 2. It is the formula, we know it. For destructive interference, it is odd number multiple of lambda by 2, or for constructive, it is even number multiple of only lambda, not 2, even number, n lambda, and n is even number, 2, 4, 5, 6, 8. And for destructive interference, that is odd number. If it is 2, if it is 3, if it is 4, it will give you odd number. Odd number multiple of lambda by 2 will give you destructive interference, and path difference should be this. And in the option, you are asked that this path difference will be any one of these 4, which will give you destructive interference at P. So one is 5, other is 4 by 3, other is 2, other is this. This will not give, because it is even number multiple of lambda, and this is odd number multiple of lambda, and this is again odd number 3 by 4, and this is 11 by 2. So let us see whether 5 comes or whether 3 comes or whether 11 by 2 comes or not. So by putting that is 1, no, 2, no, 3, no, 5, 4, no, 5, 5 to the 10, 1, 9, 9 by 2, no, 6, 6 to the 12 minus 1 is 11 by 2. So your answer is, from the above option, the answer is 11 by 11 into lambda by 2. That is, if we check for the value of n is equal to 6, we will get one option's value 11 by 2. So at path difference, 11 into lambda by 2 will show you a destructive interference at P for this arrangement. So this is a question from JEE. Don't afraid of the questions, just you please follow the question. Two identical light waves, intensity and identity, and if intensity becomes identical, in my last class I told you I is equal to I1 plus I2 root over I1 I2 cos of phi. So if you please go through the last class, that is 12, I told you, if the intensities are identical, means I1 I2 is equal to 0, I1 is equal to I2 is equal to same, identical. So in this way, if you now you are asked two identical light waves, identical means we are assume the intensity of identical, I1 I2 is equal to I0. Light waves propagating in the same directions have a phase difference delta. After they superpose, the intensity of the resultant wave, this is intensity of the resultant wave, will become very simple. You know, I is equal to I1 plus I2 I1 plus I2 cos. For phase, here you are given delta. So since it is identical, so I1 I2 is equal to I naught. We have same, assume same, I naught. So finally we are getting I is equal to what we get here, twice I naught into 1 plus cos of delta. 1 plus cos theta is equal to twice cos square theta by 2, that is 4 I naught cos square delta by 2, that is I. That is I is proportional to these two are constant, is cos square delta by 2, and it is given in one of the option I have not written. You are asked what is the intensity, resultant intensity for this condition. So when we have assumed this, we see that intensity will be proportional to cos square delta by 2. This is option is the correct option, and this question is appeared in JEE. It is a very simple question. Again, it is asked in the entrance exam. The question is the constructive interference. So constructive interference lambda into n, where n is equal to even number, and this is part difference. Nothing to explain. You are asked for part will be the part difference if the constructive interference should take place between two monochromatic light wave of wavelength lambda is equal to n lambda. N is given number, and it is twice n minus 1 into lambda by 2 for destructive. For destructive, again I am telling part difference will be twice n minus 1 into lambda by 2. Here only lambda, it is even number, that will be odd number. 7, and again the question was asked in the JEE. So in a certain double slit experiment, interference fringes 1 millimeter each are observed when light of wavelength 5000 Armstrong is used. Keeping the setup altered means slit distance is same, and the slits and the screen distance is also same. It is kept constant. What we know, beta is equal to lambda d by d. Your set experimental set is set constant. Only lambda for the first thing is used as first source of light is used as 5000, and in the second case the lambda is used as 6000. For 5000 we got one fringe width, and if the same setups without altering the setup, that 5000 wavelength is changed by another source of light with wavelength 6000. Now what will be the change of the fringe be? So for the first case, we see beta 1 is proportional to lambda 1, and these two are set up in the same distance of the screen. Slits and screen is d, and distance between two slits is d, small d. These are same, so we assume these two, beta 1 by is equal to lambda 1. Beta 1 is proportional to lambda 1. Again beta 2 is proportional to lambda 2. These two are constant, so we write beta 1 by beta 2 is equal to lambda 1 by lambda 2. So what we get, it is very simple things. The experimental setup is kept constant. So beta 1 is lambda 1, beta 2 is lambda 2. So beta 1 beta 2 is equal to lambda 1 lambda 2. So in a certain double slit experiment, interference fringes 1 fringe of interference on 1 millimeter each are observed when light of the wavelength of 5000 is used. So what if it is 5000 and another case it is 6000 and here it is 1 am and here mm, here it is 1 mm fringe width and second fringe width you are asked to find out, and lambda 1 is equal to 5000 divided by 6000, and if you solve it out I think beta is equal to 1.2 mm. So change in fringe width will be 1.2. Again this is from AI, earlier AI Tripoli. Now what is the question? Question is, in a mixture of, there are mixture of the two light is used in the experiment, and in a mixture of the light the wavelength of one light is known, it is 590 nanometer, and another unknown light of wavelength lambda, we don't know its wavelength, is used, and this is mixed up and it is illuminated on Young's double slit experiment. Young's double slit, these two mixture of the light, one is known wavelength lambda, other is unknown wavelength lambda is used, and that give rise to the overlapping of interference pattern on the screen, that gives overlapping interference pattern on the screen. The central maxima of both the bright fringe coincides. When there is a coincides means your question will be 1 and 1 lambda 1 and 2 lambda 2. Earlier I told you this is the point. The question may be very big, very large. You seek out the point from what you will get the idea is n1 lambda 1 and 2 lambda 2. Further, it is observed that third bright fringe of known light, one is third, nth third bright fringe, other is fourth. These two overlap. Third is known, third is known wavelength is overlap with fourth bright fringe is unknown, then fourth is unknown, wavelength of fourth light is unknown, and therefore known bright fringe equal to 590. You are asked to find out the lambda for unknown. Very simple. You asked 3 into 3. So the known wavelength 590 nanometer and its third bright fringe, and unknown wavelength is not known, its fourth fringe overlaps and that coincides. You are asked to find out this lambda, that lambda is equal to lambda of the unknown wavelength will be 442.5 nanometer. Very simple. It is asked in AI Tripoli, probably in this 2013. It is very simple, and the question is asked again in the entrance exam. In double slit experiment, once if this double slit experiment was done in air, and this same experiment with same setup it is done in water, you are asked to find out the width difference, width change. What is change of the width in air and in water? So you see beta is proportional to lambda. Again, from Cauchy's relation, mu is a plus b by lambda square plus c by lambda 4 plus dot dot, that is mu is proportional to 1 by lambda square. So you were asked to find out, no need to come to the mu, you are asked yes, we are come to the mu, because the refractive index of air and refractive index of water, that is refractive index of water is more. So what we have done here, the same experiment, it is done in air, and in the same experiment, and it is done in water. So lambda is directly proportional, beta is directly proportional to lambda. Again, beta is inversely proportional to this from Cauchy's relation. If you come to this one, so the refractive index of water is of air and water. Refractive index of water is more. Am I right? So more is coming here, less will be this. It is inversely proportional. When it is air, one result of B. When it is in water, refractive index is water is more. So here the denominator you are getting more. So B is less. That is B will decrease when the experiment is done in water. No method. So please go through the question. The question is a bit long and lengthy one, and it is question is asked in 2013 NEET, and the question is very simple. Again, it is not tough. Please first understand. In young double slit experiment, the slits are 2 centimeter apart. The slits are 2 centimeter apart. It is small d distance, and that is S1 and S2 are in the distance 2 millimeter apart and are illuminated by two light sources. Two light sources is used. One is lambda 12,000 angstrom and another is lambda 10,000 angstroms. Now, at what minimum distance? You are asked minimum distance from the common central bright fringe. From the central branch, this is central bright fringe. At what minimum distance means you are asked to find out x distance from the center. Minimum distance 2 millimeter away from the slit. 2 meter away from the slit. It is given capital D. Capital D is 2 meter. That is, these two slits are 2 meter away from the screen. Slit will form bright fringe from one interference pattern concert. Slits will a bright fringe from one interference pattern concerned with bright fringe from another. At what distance x? At what distance means? At what distance means? At what distance from this center? One bright fringe. The condition is the slits are at 2 centimeter apart, 2 millimeter apart, and the distance between the screen and slit is 2 meter. That is, you are given small d is equal to 2 mm and capital D is equal to 2 meter, and lambda 1 is equal to 12,000 angstrom and lambda 2 is equal to 10,000 angstrom. You are asked to find out n at what distance the bright interference from one source and bright interference from other source will coincide. Coincide means what? Coincide means what? N1, lambda 1, N2, lambda 2. Earlier I told you, and this is the formula. So N1 by N2 is equal to lambda 1 by lambda 2 equal to 12,000. So from this N1 by N2, let me fist out this one. N1 by N2, we get N1 by N2 is equal to 5 by 6. So you are asked what minimum distance. For minimum distance, one is nth is 5 one nth bright fringe is equal to in 5 number and another n is at 6 number. So your minimum n value of fringe and at fifth fringe is the minimum. So that minimum n1 is equal to 5. We have got two. One is 5, other is 6. Which one will take? This is your minimum nth value. For what minimum distance one bright fringe from one sheet will coincide with the another bright fringe of another wavelength. So we have got here n1 from this minimum nth value of the fringe is fifth number. So from this we will apply the formula bright fringe. Am I right? So x is equal to n lambda d by d. This is bright fringe. So this is the distance we are asked to calculate. At what distance from the center bright fringe that two bright fringe from two sources will coincide. So that x is equal to, what is that n? That n is the minimum n, that is equal to 5. What is lambda for this one? For this n1 is lambda is equal to 10,000. And what is d? D is equal to 2. And what is that d? D is equal to mm is equal to 2 into 10 to the power minus 3. 2 into 10 to the power minus 3. And you have to do here, 6 it is in m. So Armstrong should be changed. Am I right? So 10,000 Armstrong greater to minus 2 to centimeter equal to 2 into 2 to centimeter equal to 6 mm. That is from the center fringe at 6 m. The two fringe of two wavelength, bright fringe of the two wavelength, one is 10,000, other is wavelength 12,000 will coincide. This is the answer. And this is the last question probably, and this question was asked in IIT. It is very simple question. Young double slit experiment is carried out by using three types of light: green, red, and blue. Green, red, and blue. And the fringe width is found as beta G and beta R and beta B. And you are asked to which option of the following option is given is correct. Means which fringe width is greater, which one is smaller and smaller and smaller. Arrange the fringe width in order. Am I right? So we know beta is equal to what? Lambda d into d. That is beta is directly proportional to lambda. Since it is IIT, question is very simple, not tough. So we know lambda r is equal to greater than lambda g is greater than wavelength is known to us, lambda is known to us. So more the lambda board is this. Therefore answer is b r beta g is greater than beta b. So this is all about today's class. Please don't forget to subscribe to remain updated. Thanks a lot for watching the class.